Okay, our next example, we want to rewrite these with positive exponents. Remember, it's not simplified if we still have negative exponents in the problem. So that's where we're going to start. So we have 2a to the negative 2. So to get rid of negative exponents, we either move it to the denominator, or if it's already in the denominator, you would move it up to the top. So to deal with this a to the negative 2, we are going to move a squared into the denominator. When we do that, that gets rid of the negative exponent. Now, the coefficient 2, it does not have a negative exponent, so it doesn't move. It's got to stay on top. So this simplifies to 2 over a squared. Okay, in B, we can do this a couple different ways. We can subtract our exponents first, or we can move things first. So I'm going to move things first. You don't have to do it this way. But I'm going to say, look, this a to the negative 3, I'm going to move that down into the denominator. That gets rid of the negative. And the b to the negative 1, I'm going to move that up. So that way I can just get rid of all of my negative exponents. So I have 3 on top, b to the 4th is still up there, and I've moved b to the 1st up there. On the bottom, I have 15a, and I moved a cubed down there. So let's take care of those b's. B to the 4th and b to the 1st is b to the 5th. You add those exponents. A to the 1st and a to the 3rd is a to the 4th. And now we need to take a look at these numbers, okay? 3/15. You can reduce that fraction. Both of those things are divisible by 3. So that becomes a 1 and a 5. So we don't need to write the 1 at the top, but we still have a 5 in the denominator. So with the numbers, with the coefficients, remember they're not exponents, you don't subtract them, just reduce them like normal fractions. So b to the 5th over 5a to the 4th. Okay, see, there's multiple ways you can go about this. Probably the easiest one to think through is to distribute this negative 1. So we get x to the negative 1 over 10 to the negative 1. Now, to get rid of those negative exponents, we're going to have to move them. The x is going to drop down, the 10 is going to come up. So we end up with 10 to the 1st over x to the 1st. And that's it. All right, in D, we are going to distribute this cube to everything in its parentheses, and we're going to distribute the negative 1 to everything in its parentheses. So we get negative 2 cubed. Multiply your exponents here, x to the 6, and don't need parentheses there, that's a negative number. 4 to the negative 1, x to the negative 3, multiplying those. So now what I'm going to do is I'm going to take everything with a negative exponent and drop it down. So the negative 2 to the 3rd and x to the 6 is going to stay on top. I'll drop down 4 to the 1st and x cubed. All right, so let's go ahead and clean this up. Negative 2 to the 3rd is negative 8. So negative 8x cubed over 4x to the 3rd. Now we have x's on top and bottom, so we can subtract those exponents. X to the 6, x to the 3rd, we subtract those and we get x to the 3rd. That's a positive exponent, it'll be on top. And then we need to treat these numbers, just treat it like a fraction. Those are both divisible by 4, so that's a 1, this is a negative 2. So we end up with a negative 2 on top. And we just have a 1 in the denominator, so we actually don't need to write that. We can just leave our answer right here, negative 2x cubed. Okay. And that's not the only way to do this problem. If you did it in a slightly different order, there's lots of options that you can do things different as long as you end up with the same answer. Okay, so when is this used? It's used in scientific notation. For those of you who are into more science fields, when we talk about really big numbers, you know, the distance between stars, or really small numbers, you know, the diameter of an atom or something, these are really big and really small numbers that we have to deal with, so we write them in scientific notation, which I know you're familiar with. If you cannot remember scientific notation, check out your book. Examples number 5 and number 6 are how to write things in scientific notation. But I didn't think we needed to go over that right now. But we can use our properties of exponents to do operations with scientific notation. For example, this very large number. I'm going to write it in scientific notation. It's 2.4 times 10 to the 10th, I believe. Okay, and then we want to multiply that by this number. So in scientific notation, that is 1.2 times 10 to the negative 7. And then we have this number, which is 3.0 times 10 to the 5th. Now we want to multiply these things together, which really isn't a problem. We're going to take our numbers and just multiply them. I'm going to grab my calculator for this just so I don't have to do it in my head. 2.4 times 1.2 times 3. And that gives me 8.64. Now, this number is going to be in scientific notation. So times 10, and then you're going to take your exponents and you're just going to add them. So 10 plus negative 7 plus 5 will be 8. So our answer is 8.64 times 10 to the 8th. So it's way easier than multiplying with those massive numbers. Scientific notation is very helpful. In the next video, we will talk about radicals.